In this lesson, moving forward, I'm going to talk about the binary literals in Java. Now, typically we use decimal formats, right? So if you need to write a number, we simply write 10, 11, 12, 13, and so on. But there are other instances and ways that we can also use the binary literals. So what is in fact a binary literal? Is simply a new feature, basically starting in Java 7. And we know that we can write the integral types, for example, like byte, short, int, and long, in binary and hexadecimal formats. But from Java 7 onwards, for example, we can write these numbers in binary format as well. So the number should be prefixed with, let's say, 0b. B could be in capital or lowercase, doesn't matter, to be treated as a binary literal. So the feature is helpful to bit-oriented systems like processors, for example, network protocols. Let's say you're doing socket programming and writing Java programs, right? So you would need to know the binary literal programmings. And with that, obviously you also need to know how to convert from decimal to binary and the base 10 and base 2 systems. So for those like network protocols and bitmap hardware devices, so the programmer early on used the transform from binary to decimal to hexadecimal, for example, and vice versa. And using this feature, you can remove the transformation and chances of error will be less in this conversion. So that's why you would use binary literals in Java. So I'm going to demonstrate next how to actually use these, what do they look like, and what the real benefit is. And as a network programmer, for example, or you're writing a program in Java, this is very helpful. So let's jump right in. Let's navigate to the Eclipse editor. So once I'm in the Java Eclipse editor, before I in fact start a new program, there are different literal types. So we know about decimal, right? Fairly straightforward. For example, if you were to declare a variable such as num equals 20, straightforward. Decimal 20 is assigned to the variable called num. If I need to write this in octal, for example, that's a different literal type. So I'd be write something like int num equals 020. So let me in fact demonstrate this so it's easier for you to visualize. So for instance, I'm just going to go ahead and enter some spaces here so you can see, just so that you can visualize what I'm talking about. So different literal types. So typically if I were to do something like int num, for example, equals 20, right? Straightforward. That's a decimal 20 is assigned to a variable called num. Now if I were to do something like int num equals 020, and this would imply an octal number, right? So this is an octal number. So the first octal number is basically converted into integer, and then it is assigned to the variable num. Another type is hexadecimal, for example. So this could be something like int num equals, and hexadecimal format is 0 times 20, right? So this is basically hexadecimal number. Okay, just giving you an idea of different types of literals. And here I'm just writing some assignment statements just so that you can actually see. I'm not writing a program yet. I'm just defining basically different literal types. So next one could be binary. And that's exactly what we're going to use in this lesson. So it'll be something like int num equals, and as I mentioned earlier, binary always starts with 0b, right? So you can use lowercase b or uppercase, it's the same. So 0b, for example, 1010. So this is the binary number. And you can assign this to the variable num, right? That's what we actually did here. And then we also have the long num, for example. So if I do long num equals something like 563L, this is basically a long number assigned to the variable num. But primarily in this lesson I'm going to focus on the binary literals in Java. Okay, although there are others as well, but here I'm going to write a couple of programs so you can actually see how this works. Perfect. Let's move on. Let's go ahead and create a new class. First, I'm going to write a simple program. I'm going to create a class and then demonstrate the binary formats first. So right click on my default package, click on new, click class, and I'm going to call this binary underscore literal. Click finish. Perfect. Let's go ahead and let's do our code. So I'm going to go ahead and do public static void main, of course our string and our command line argument. Open the curly braces, and next I'm going to start with, let's say I'm going to start off with byte, and I'm going to call this variable New York. You can call it anything, right? So this is going to equal, let's say, a binary format number, right? So I'm going to say something like 0 B 0 0 1 0 0 0 0 1, right? So any binary number, semicolon, and then for the short type I'm going to say Chicago equals, and once again just a number, let's say 0B 101, and then 4 zeros, 101, couple of additional zeros. And once you know the binary decimal conversion, you will know what this number represents. So moving forward, a few different examples like int. I'm going to say A1 for example here, and this is going to be OB 10110, something like that. Semicolon, let's get A2, and then I'm going to say 0B 101. By the way, this is a 0, not an O, okay? So keep that in mind when you work with binary numbers. So let's go ahead and do one more. Once I'm done with this, I'm going to go ahead and do int A3, and this is going to equal 0B 1011, something like that. Alright, once I'm done with this, I'm just going to add these up. So let's go ahead and do int al equals A2 plus A3. So just as an example, right? And of course I need to fix up the syntax. This is 2 in fact. Perfect. And next I'm going to go ahead and do the system.out.println, and I'm printing, let's say, the byte value first, and this is in quotations. And of course I need to concatenate this with New York. And I'm going to do the same for the rest of them, right? So let's go ahead and do system.out.println, and I'm going to go ahead and use the short value, and this is going to be for Chicago, right? And let's do a couple of other ones. So system.out.println, and this is going to be for the integer value, colon with a space, and I'm going to concatenate this with, let's say, A1. Let's do maybe one more, like system.out.println, and here I'm interested in the result, colon with a space, plus AL, right? So I want to print that also. Great. So just a simple example of different binary numbers. Let's see what happens when I execute this. So let's click on the run button. Save and launch dialog box appears. Click OK. And of course it gives me errors in the workspace because I demonstrated the binary literals in one of the existing files, the iterators.java. So I'm going to go ahead and fix that quick. So let's navigate to iterators.java here, get rid of this, We don't need this anymore. All right, great. So let's go ahead and get back to our binary literal. Here we go. Let's run it again. Click OK, and perfect. So we get the byte value of 33, which is this binary number, and then we have the short value of 2580, which is the next one, and then of course the integer value of 22, and the result is 16, which is the addition of A2 and A3. So just to give an idea how to actually work with binary literals in Java. Now of course I can always add additional variables to this. So let's say if I would like to do something like int, just A4 equals, and this could be 0, B, and just some binary numbers, right? So 10110 10101, something like that. Okay, not 4, just ones. Great. And of course a semicolon. And if I need to print this out also, let me just go ahead and do a quick system.out.println. And here I'm just going to print out, let's say, my value, colon, space, and then of course A4. Great. Let's run this again. Click OK. And of course we get my value as 1461 in decimal format. So you understand the binary literals in Java. Now another couple of tips that you can actually work with is these binary numbers can grow really long, right? So for example, this number for the Chicago variable is long, and sometimes there's just too many zeros and it's difficult to visualize and see and count those zeros, right? So the easiest thing is to break these by using the underscore option. So for example, if I were to, let's say, do underscore after every 3 digits, right? So underscore, and then place an underscore here. Likewise, like so, right? So what's going to happen is, first off, it's easier for you to actually see. You can pair these zeros or numbers, right? In 3s, 2s, or whichever format. The only thing you cannot do is you cannot place an underscore after B, right? So I'm going to demonstrate this next. But first, let's go ahead and place these underscores and then run this. See what happens. We should get the same value. So click on Run, Save and Launch dialog box appears. Click OK. And perfect. We still get the 2580 for the short value, which is our variable Chicago, right? So this is a good way to identify, especially when you're working with network programming or protocols or socket level programming. You're just working in binary, right? So there's just ones and zeros and ones and zeros. So it's easier for you to use the underscore. Now, you cannot use the underscore right after letter B. So if I were to use this, notice it's going to throw an error, and the editor is going to say underscores have to be located within digits only. Okay, so you need to make sure that you specify underscores after digits. Now this could be after every single digit or every other digit or 2 or 3s or whatever, right? But as long as it's after digit. So if I go something like this, right, place underscores after every digit, it's still going to give me the same result. So let's test this out. Run this again, click OK, and of course we still get the 2580. So in this lesson we worked with the binary literals in Java, and of course by default an 8-bit or byte literal value, by default literal values are int, right, that I use as A1, A2, and A3, and of course I can cast it to use the byte New York and so on. So you can use any other form, whether it's a 8-bit or a 32-bit literal. You just have to add some binaries to it, right? So 32-bit binary would be a fairly long binary numbers with a bunch of zeros and ones. Now I did not cover the conversion from binary to decimal and decimal to binary. That's something that you can actually look up on your own. But once you get to practicing, right, these binary numbers and working with Java, it'll be very easy and helpful. And you'll practice and things will be smooth for you. So just practice working with these binary numbers. Understand the conversion also on your own. That's a practice task for you, by the way, on your own. And then let's move to the next lesson.